All right, good afternoon, everyone. My name is Rob Knight, and I'm a technical strategist here at SUSE. I cover EMEA, and it's my job to help our guys in the field with our application delivery products, as well as SUSE Manager as well, and my colleague.
Jonas Forsberg, work as a sales engineer, pre-sale, located in Scandinavia, Northern Europe.
Thank you. So yeah, we're here to give you all a quick kind of talk about SUSE CaaS Platform. You know, why the product exists and some of the benefits that it can provide for your business. This is a business overview session, so we're not going to really talk about anything too technical at all. You know, it's more sales orientated than technical. But if you do have any questions at any time, just pop your hand up, and I'll be more than happy to answer them. And it makes it a lot more interesting when I get lots of the interesting questions from you guys. So, as I'm sure you're all aware, technology and the trends in technology are really changing, especially over the last couple of years or so. We've got a lot of new trends emerging, things like AI, machine learning, a whole new areas for your business to explore. And for many of you in leadership positions, those kind of business requirement demands are now going to be fed down from high up. Saying we want to be more agile, and as a IT organization, we need to start embracing AI or ML technologies, for example. And it's really these kind of trends and changes that are driving adoption of a lot of our more modern products, such as SUSE CaaS Platform. Now, along with these products can often come a lot of business change as well, and depending on where you are in the business disruption potentially, and you may have to change the way that you kind of work, or the way that your team members work and look at things. But ultimately, without these kind of innovative trends and changes, your competitors will implement them. So whether you're a partner that's looking to sell some of these technologies to your customers, or an end user of some of them, these yourselves, it's really kind of important to embrace these changes, understand the impact to your business, and kind of to explore how SUSE can help you with some of these changes. So, a big kind of buzzword on the slide there, microservices. And this kind of really ties in with the core kind of value proposition of SUSE CaaS Platform. Back in the days of mainframes and centralized architecture, big central systems serving all customers at once, and then we kind of evolved towards a multi-tier architecture, breaking down a component system into slightly smaller parts, but still relatively large or immovable parts. And there's this latest trend of microservices, going that one step further, breaking down an individual kind of component into as smaller pieces as possible, and tying those pieces together with APIs. And kind of containers are really kind of central to the microservices story. But let's take a very kind of quick look at what a container is at a high level. Fundamentally, it's a package, or image rather, that can be deployed somewhere. Now, we often say it can be deployed anywhere where you've got a running Linux kernel, in the case of Linux containers. Obviously, we've got Windows containers as well now. But the idea behind them is that your developers, or potentially a vendor of yours, their developers, will create an image of their application that contains everything that application or service needs to run. That application is based on top of a base layer, like an operating system layer, for example. And once that image has been built by the developer or team, it can be reproduced and then run anywhere. Rather than kind of rebuilding, the developer or company will just ship the image, and then that same image will be run everywhere. It can really help developers focus a bit more on what they do better, which is software development. They don't have to deal as much with packaging or library issues. So say, for example, a lot of companies, they may say use OpenSUSE when it comes to development, but then SLES when it comes to running in production. In the case of containers, the developer can, if they so choose, package up all of the upstream or OpenSUSE-based dependencies that their application has, and then ship it to run on that production SLES system. It can be really flexible in that way, and there's lots of policies which companies often have to change to try and enforce, well, actually, no, we've got these approved upstream sources, you must use them, and there are some tools in place that can help with that. But what it means is the developer can pick and choose. They know their app or service best, they know what it needs to run, its dependencies, so they can kind of package all of that into that single container. What it also, from the kind of operations side, it allows an ops team to deploy an entire application stack in seconds. They don't have to build individual environments like we used to before. You know, we would build an environment, make sure all of the dependencies were installed, and then deploy the application following the dev's instructions on top. But we don't need to worry about that anymore, because all of the dependencies are now packaged into that single image that we will then go and deploy. Now, looking into kind of how this fits in a little bit more with microservices. Now, containers themselves, they offer a very finely grained execution environment. It will include, like I say, everything that's needed for a specific app or service to run. What we can also do, though, is cohabit more of the same service or all sorts of services onto the same physical machine or virtual machine that we had before. So increasing density. You know, often in the past we'd have an individual virtual machine where we would then run a single service or application. But because everything is now packaged and isolated up, we can run multiple instances of the same application or different versions of the same application on one virtual machine or physical server. In addition to that, containers, they stop and start really quickly. You know, they've got fast initialization. Depending on the app, a few seconds isn't abnormal. And this can really help when it comes to scaling, you know, or dealing with changes in demand response as well. But kind of looking back into actually how we produce software, when dealing with containers, it goes kind of hand in hand with containers, really. You have different teams working on different functional aspects of an overall solution. And each one of those components, each individual microservice, will be potentially in a different phase of the software development lifecycle at different times, and that's okay. And you know, containers can really help enable those kinds of changes, because as we drive towards microservices, we're driving towards smaller code bases. Those code bases are going to require specialized teams that work on those code bases, and deconstructing the services overall. It really is the kind of the embodiment of Agile IT, rather than having your entire development organization working on one specific project at once. You split those up into, say, 10 or 20 specialized teams, all working at their own pace, in their own language, on the kind of the functional aspect of the overall solution that kind of fits their skill set best. And containers tie in really nicely to this. But there are some traditional kind of issues with containers in terms of core operational technologies, you know, load balancing, how to scale them and how to monitor them. It's done in a very different way than the way that we're used to. If a developer or operations team is working, with just individual containers, it can be quite easy for things to get out of hand, to lose track of what containers are running where. We need orchestration in place to ensure that the right container is running on the right server with the right dependencies at the right time, and especially when dealing with microservices, because everything is kind of interlinked and talking to one another through APIs, ensuring that the network fabric is in place for that. Things like service discovery, for example. We need all of those to be provided as well. Now, you can build all of those yourselves, especially if you've got a smart development or DevOps team. But many companies, start going down that path and kind of realizing that, building a container stack isn't for them. They're very complex overall systems. The containers themselves may be quite small and lightweight, but the systems that manage containers can get very complex very quickly. We often say that organizations need containers to be more consumable. From an enterprise perspective, you need a tool that can handle the automatic scheduling of containers. As I mentioned earlier on, making sure that the right network facilities are in place. Automatic provisioning of storage, for example. But in addition to that, for example, when it comes to updating containers or rolling out a new version of a service that's running in a container, making sure that we launch those new versions before destroying the old versions so that your app uptime doesn't suffer. These are all of the things that we really need when deploying at enterprise scale. And this is where Kubernetes comes into place. Kubernetes now is kind of the de facto leader in the container orchestration space. There's a few different technologies out there, but Kubernetes has really emerged as the number one container orchestration technology. It provides all of those things that I was talking about just now and more. Self-healing, monitoring of the container, making sure that if something goes wrong with the container, it's automatically restarted, for example. Kubernetes is used by many companies now, around the world, and there's a lot of different Kubernetes vendors. There's obviously ourselves. We've got Red Hat as well with OpenShift. All of the kind of major OS vendors are in the Kubernetes space as well. We've all kind of chosen Kubernetes as the best container orchestrator, which also gives you a lot of choice as well of which container platform you choose to run, because as long as it's based on Kubernetes, it can be quite easy to port those workloads to other Kubernetes environments, with the exception of OpenShift, because they make a few changes to the base Kubernetes. So in terms of providing that, as Neil said this morning, open source, us choosing Kubernetes rather than kind of making our own from scratch helps enable you and enable your customers in that area as well. And this is where SUSE CaaS Platform comes into play. So it's an enterprise grade container management solution. It helps you and your customers get up to speed with containers quickly, secure the container platform really easily, as well as manage and scale that container platform as well. Now, another technology you'll hear us talk about over the course of this conference as well is SUSE Cloud Application Platform. And I kind of just want to touch on the difference, because sometimes the messaging can be quite similar. We say it's a platform for application delivery or a platform, to enable you to develop services. SUSE CaaS Platform is primarily designed to deliver Kubernetes, to give Kubernetes to your organization. It doesn't deal so much with the applications on top of Kubernetes, whereas SUSE Cloud Application Platform is our distribution of Cloud Foundry. And as part of that distribution, we also include Kubernetes. Now, if running cloud application on premise, customers will often choose to run that on top of SUSE CaaS Platform. So you can almost think of it as SUSE CaaS Platform as Kubernetes, and SUSE Cloud Application Platform as an application or framework or suite that's installed on top of Kubernetes that gives you some additional services and abstractions for your developers to use. But I'm mainly talking about CaaS Platform today. But yeah, sometimes there can be some confusion between the two. So CaaS Platform at the moment is based on 3 main technology components, and any container management platform is going to have an orchestration layer. And as I just mentioned, we've chosen Kubernetes as our orchestration tool of choice. In addition to that, there is often going to be an operating system that the containers are run on top of. At the moment, SUSE CaaS Platform has its own operating system called SUSE MicroOS that's based on top of SLES. But I encourage everyone to go to the CaaS Platform roadmap session, run by our product management team, to see how that's going to change in the future moving forward. And finally, there's going to be configuration. So what's actually managing the nodes, what's managing everything in the infrastructure. And at the moment, we use Salt for that, our configuration management tool of choice. In addition to that, container engine support. So we support Docker at the moment, and we've got Cryo as well, a new container engine that we've got in tech preview on CaaS Platform 3. So kind of looking at what we bring to the table. When we say achieve faster time to value, what we mean is it helps you get up and running with containers really quickly. We've taken and chosen all the kind of different and best, in our opinion, technology components, configured them and integrated them together for you. It's got an incredibly easy installation and configuration on top as well. And when we say enterprise ready, those of you who have been using SLES for years, can have trust in us to deliver an enterprise operating system. We've applied that same logic and mentality to our Kubernetes distribution as well. Simplifying management and control. So Kubernetes traditionally was very hard to get up and running. It could take days potentially for engineers to get a platform up and running, and knowing the right defaults to choose, right settings to choose, and of the hundreds of thousands of options was quite a challenge. We've kind of gone through and chosen the sanest defaults that make sense for our customers, and that provide a secure and enterprise hardened version of Kubernetes out of the box. In addition to that, adding and removing nodes, growing and shrinking your cluster is really easy. Scaling Kubernetes is really easy. It's as simple as provisioning another node and pointing it to the existing infrastructure. And then you go into a web interface and click go effectively. Update automation as well. Because SUSE MicroOS is based on top of SLES, it receives updates in a similar way to how you do for SLES. You can deploy an SMT server to receive updates. And getting those installed is a simple matter of clicking install update in the web interface as well. And finally as well, in terms of maximizing the return on your investment, as mentioned, we've chosen industry standard technologies to go into SUSE CaaS Platform. In line with all of the other main vendors. This isn't going to, these aren't going to change anytime soon. In terms of how it fits into, the broader kind of IT transformation piece, it really goes down to, if you're producing code over time, it makes sense to start investing and looking into developing microservices. And as you start investing and looking into microservices, you're eventually going to choose containers as kind of the platform of choice to run those on top of. And as I mentioned, you're then going to need a container platform to run those on top of. CaaS Platform, also is cross-platform, so it doesn't matter where you're running it, whether it's public cloud on top of VMware, for example, Hyper-V or Zen. All of those are supported at the moment. So depending on where you deploy or where you want your application to run, it's the same underlying platform as well. Just kind of looking in terms of the technologies that we include today with CaaS Platform. Obviously Kubernetes there in the middle, our core container orchestration technology. And this is a certified distribution of Kubernetes as well that we've got. In terms of some additional features we provide, we make it easy to integrate with an existing LDAP or Active Directory environment. Application services on top. We now provide the SUSE registry, which is a trusted registry where you can get your SUSE-based container images from, SLES-based container images. Looking as well down, we provide an OCI compliant container runtime engine. In terms of networking, Kubernetes ships with its own software-defined network as well, which we set up and configure as part of the platform. And from a storage perspective, if you've already purchased or are thinking about purchasing SUSE Enterprise Storage, we make it really easy to integrate Kubernetes and SUSE Enterprise Storage as well, but also provide NFS support if you aren't going down the SUSE Enterprise Storage route as well. As I mentioned, today we provide a multitude of different deployment options, from bare metal to all sorts of different hypervisors, but also public clouds as well. All kind of giving you the flexibility of where you run Kubernetes and your container platform. And although yes, in public cloud, obviously Amazon and Azure, they have their own Kubernetes distributions running up there. There's nothing stopping you from using both as well. And what that means is it's the same Kubernetes distribution that you're running on premise as you are running in public cloud as well, which makes it kind of easier to test your applications. It makes no sense testing a completely different architecture on premise as you do on public cloud. But also as well, on public cloud, things like Kubernetes versions, they're updated and they change quite rapidly. You can log on one day and find that AWS have dropped support for a specific Kubernetes version. Obviously, whereas with SUSE CaaS Platform, we have a published support policy for our Kubernetes updates and provide you with a bit more flexibility in that area. Now, before Jonas comes in and kind of talks about a couple of customer success stories that he's experienced, kind of what does all of this mean, or a couple of kind of takeaways from SUSE CaaS Platform. Responsibilities, as I mentioned, will change within your organization. Traditionally, as I say, the ops team would have taken instructions produced by developers, built a series of VMs for the app to run in, and then deployed the application on top. What we often find now, and what's encouraged, is for the ops team to build and manage the Kubernetes layer. So they'll build and deploy SUSE CaaS Platform, but it's then up to the developers to deploy the workloads on top of SUSE CaaS Platform. And that's kind of all part of embracing Agile and DevOps, really, kind of shifting responsibility for the apps towards the developer, which makes sense. They know their app inside and out. In addition to that as well, that's what I say when I say operations team focus on the platform. The ops team will still manage the storage layer, they'll still manage the Kubernetes layer and make sure that Kubernetes is up and running, but they'll provide classes of storage or networking that developers can then consume. A developer will say, I need 10 gig of storage when they come to deploy their application, and Kubernetes will automatically provision that for them on top of SUSE Enterprise Storage. They don't need those storage skills that have traditionally been within the storage team as well. When we talk about kind of culture of blame shifting, as application developers become the ones that deploy and operate their application, the ops team can no longer be blamed when the application goes wrong. I've worked in ops and that would happen more often than not. But by shifting that responsibility, what will ultimately happen is the development team will start talking to the operations team more. The developers will say, we need this version of Kubernetes, or we need this specific API that Kubernetes provides. Can you enable that for us? And then they're quite happy to manage their applications on top of the platform once those kind of changes happen. But kind of ultimately, Kubernetes isn't a magic bullet. We talk about it a lot at these kind of conferences. One of the kind of main problems that I've seen in the field is when an organization will go and purchase a tool like CaaS Platform, but they won't change their procedures, they won't change their way of working. They'll try and apply the kind of legacy way of working, the legacy way of that they're used to working with virtual machines towards CaaS Platform. For example, CaaS Platform by its nature is fully highly available and will automatically reschedule workloads if there's a problem with a node, for example. And it's when an organization tries to take more control of that process, manage everything manually, just like they used to in the kind of the old way of working with virtual machines. That can be when kind of problems can crop up, simply because Kubernetes isn't designed to work that way. You can't just take your existing application, run it on top of Kubernetes with no changes or planning into how Kubernetes actually manages containers and what that might mean for your application. Kubernetes is really best for stateless applications. There are capabilities for managing state or persistent data, but what we often find is organizations work best when they start thinking about what parts of their infrastructure can be containerized and what the quick wins are really. They've got a whole load of existing monolithic applications that they use. It's about identifying what parts of those can be broken off really easily and quickly and turned into a container and then run on top of something like SUSE CaaS Platform that they get that kind of the most benefit from it. Dive in knees first, so to speak, and get that exposure early rather than trying to do a big bang migration of everything. Suddenly the next day has to be on top of Kubernetes. Talking of customers, Jonas is going to come up and share a couple of his experiences working with our customers.
Thank you, Rob. Sorry. Yes. That is an English word I have a hard time to pronounce, so help me, Rob. The municipal. Thank you very much, Rob. We had a discussion with an operational team in Scandinavia, and they were hit quite hard by their internal developers developing services and tools for a lot of users, a lot of schools, and they actually produced a lot of services for the neighbors as well. And the operations team didn't know what a container was, more or less, but the developers said, this is what we need. Could you please provide us a solution for this? And they gave us the opportunity to talk to the operations team and do an initial meeting. And during that operational meeting, the customer itself identified, as Rob said, this is a core infrastructure part, which involves a lot of different responsibilities, all from application to server, network, and storage. So they quickly identified that they need to involve all the silos within their legacy data center approach to be involved in this project. Now, I don't recommend everyone to do what they did. They did a lot of pizza evenings, designing the solution and how the application should be developed and how the network should be configured. And because every responsibility was in the room, the time for actually seeing a problem and coming to a solution was really, really fast. And they were so comfortable with this technology and how we did it together with them that they went directly from nothing to production in a really fast pace. And they also identify that they actually need more than one Kubernetes cluster to actually provide what the developers wanted from them. So any questions about this particular use case? Well, if it is, if you have them, just raise your hand or catch us afterwards. The other one is not a complete success story yet. It's a success story waiting to happen. It's a proof of concept that we are running with a manufacturer in Sweden. They manufacture hard, heavy tools, and they have a lot of development, internal development for the manufacturing sites, which are spread around the world. So they are actually going to do, well, they currently have a monolithic application, which they have a lot of monolithic applications that they have developed themselves. And they can't cope with all the new types of data being sent to the application from all the IoT devices they are implementing in the factories. So they need a faster pace for catching that data, analyze that data, and they need to develop that application layer in a much faster pace. So they are looking to refactor the complete application stack and create a microservices approach. So the development is previously on all Windows, and they are .NET programmers, but they have chosen to go to .NET running on Linux and are looking for a Kubernetes solution as well. Now the development will be done in Azure, but they can't do the production in the public cloud. They have to be within the factory site for a lot of different reasons, and that's the reason why they want to deploy a SUSE Container as a Service platform on Azure instead of using Microsoft's container service. So they have the same experience, the same binaries, the same everything in the development as well as in the production. What they are doing now, and which are quite important, I think, is creating a CI/CD, the continuous integration and continuous deployment pipeline. So most of the work of deploying, pushing code, deploying containers, testing the containers, and moving them from test to from development to test into finally dropping into production is done as much in automatic manner as possible. We shouldn't do anything really in a manual way within a Kubernetes cluster. That's my personal opinion. So hopefully this will be a success story for next SUSECON, so stay tuned. This is a cliffhanger for next session. Any questions? But as Rob said, we are not the only one creating a Kubernetes solution, of course, and the customer chose Kubernetes as the orchestration platform just because they wouldn't be locked in. They could go public. Both Amazon, Azure, Google Cloud has their Kubernetes offering, and there are a lot of different vendors that provides for running it in your own data center as well. Yes, and that's it, I think. I think we have a conclusion here from Rob as well.
Well, yes, kind of, yeah, just repeating everything that I said before. Jonas here, you know, microservices can help achieve or enable IT transformation, and as I say, you know, containers are the ideal choice for microservices for deploying them, and you know, SUSE CaaS Platform can be the key to realizing that at production enterprise grade. So yeah, we'll be here all week, and if there's any questions, feel free to ask now or approach us at the end of the session. We've got a big team that's able to help support in terms of doing product demos, proof of concepts, and supporting you throughout the whole kind of evaluation and sales cycle. So feel free to speak to any of us if you're interested. Thank you.
Thank you.
Oh, question.
Question.
That's correct, yeah. So yeah, the question is for the recording. Yeah, SUSE CaaS Platform doesn't have enterprise in the name, but is an enterprise product. And absolutely, yeah, it's built from the same enterprise sources that we do for SLES from the operating system perspective. And we support it in exactly the same way we do all of our other enterprise products. We've got a support team to help deal and all the way up to L3 bug fixes as well. So we do provide that full enterprise support capability.
Is it released on service packs like SLES?
So it's not, and the question there just for the recording, is it released on service packs like SLES? No, it's not. Because of the nature of Kubernetes releases, we follow a more of a rolling release model. There are plans to change this slightly in the future. We do have an individual major release. The current one is SUSE CaaS Platform 3. During that major release timeframe, we have updated the major Kubernetes version that we've shipped. Moving forward, I know there are plans to indicate that more. With our version number, for semantic versioning as well. But yeah, there's no service packs like with SLES. Currently though, CaaS Platform 3 is based on top of SLES 12 SP3. And go to the roadmap session by our PMs to kind of find out how the future looks for 4 in that regard as well. Thank you, good question. Okay, so yeah, the question there, will there be support for IBM Power? I am looking over at Klaus, who is our project.
Since it's open source, it's less of an engineering question, more of a business case question.
We've not had the request come through yet for it on Power. We get asked the question a lot for Power, but when it actually, from a sales perspective, comes down to defining that use case, we've not had many customers interested in working with us on that. Mainframe we have though. Had more interest, I should say, but we don't have any plans at the moment. We want to make sure that we invest our engineering effort into making sure that the product we've got is the best product that it should be before looking into other platforms as well. Any other questions? Okay, thank you everyone.